Today we are doing lesson 5.6b, which is indirect proofs, also known as proofs by contradiction. So what is an indirect proof or a proof by contradiction? As covered in 5.6a's lesson. This is where we are going to temporarily assume that the proof is false, or the opposite of the proof, which is going to lead us to a contradiction. And once that contradiction happens, we're basically saying it is impossible for the proof to be false, therefore it must be true, right? So again, as a reminder, a temporary assumption is the opposite of the proof, or that the proof is false, right? Now, this is most of the time because, in our next example, or we can even kind of skim through, our proofs and our given are going to be a little goofy on these. Not congruent, not congruent. Not equals. Not congruent, not congruent, right? So, in these situations, they aren't really proofs that we could use going the other way anyway, right? We don't have information to do. So we've got given, AB not congruent to BC. And now we have to temporarily assume, and it's always abbreviated TA, but I'll write it out this time as a reminder of what it means. And then we're going to flip the proof. So it's the opposite of angle A not equal angle C. Almost every single one we do is going to be like this. It's not going to make our proof unusable. It's going to make it into something we can use. Right? Angle A is congruent to angle C. So go ahead and label that in your diagram. Also be aware, it doesn't happen in this one, but there may be times where your given still has something we can use. In this situation, we cannot. Right? That piece is there for us to contradict. So angle A and C being equal would make this isosceles, right? These opposite sides would be equal. So AB would equal BC. And then we right away, again, that was base angles converse, so we use base angles. And now we already have a contradiction. These two steps contradict each other. Now, you will start to recognize that most of the time your given is going to have something that sticks out like a sore thumb in the fact that it's going to be a not congruent, not parallel, not equals statement. That is a statement we are going to contradict. So right there, we get a contradiction. Next step is automatically contradiction. And then you are going to restate the proof, right? Just like we always end with the proof being our final step. The proof is still our final step. Okay. And that is how a proof by contradiction is going to look and work. So again, why do they work? Basically, we show it's impossible for proof to be false. Therefore, it must be true, right? Just want to abbreviate there. Why don't we do direct proofs instead? As you've seen, generally we can't. It's not like we choose to do indirect proofs for fun. We can't. They don't give us information to prove directly. Moving on. Splitting up some of these two-column proofs with algebraic proofs. Now, a little note, algebraically means we are not doing two columns. You'll have a couple on the worksheet for homework. You are not doing two columns. Just go at it, right? Given triangles isosceles, prove base angles cannot equal 92 degrees. So we're going to just do TA. Let's say base angles are 92 degrees. So again, making up a triangle, they say ABC. We're going to say, let's say angle B and C, right? You get to pick. Two of the angles are going to be base angles. So let's say both of those are 92 degrees. What's going to break? Reminder, triangles add to 180. So by substituting in here, we've got A plus 92 plus 92 is 180. Solve for A. And I get angle A is -4 degrees. That is not possible. You can't have a triangle with a negative angle. If you try to draw the picture, you realize it would work too. And there's our contradiction. Contradiction, base angle cannot equal 90. Next, GF not congruent to GH, GLF is equal to GH. Prove FL is not congruent to LH. Now, some of my diagrams may not be drawn to scale. Some things may look congruent that aren't. But generally, you can still use the diagrams as normal. Like if there's a reflexive, we can still use that. Okay? So first, fill in what you have. So GLF, GLH congruent. And then we have, so we got a label. Next, temporarily assume that FL is congruent to LH. And again, just a note for those who are already scared of these proofs, it will be told to you that these are proof by contradiction or indirect proof. So you won't be guessing a different proof and then realize you need to do it by contradiction. It will be stated, prove indirectly, so we will know step 2 is temporary assumption and so on. This is a 6-stepper. We're going to fill in FL and LH are congruent. And now looking at my diagram, I see we are one side or angle away from triangles congruent. Right here, GL is congruent to itself as a reflexive. And then we're going to have triangles congruent. Now, triangles congruent isn't the contradiction. This is, but that will be in my congruent triangle. So GLF is congruent to triangle GLH by side angle side. And then step 5, we're going to say GF and GH are congruent. And there's our contradiction, right? So if it was, right, if our proof was false, we'd find out that our given would have to be false, right? Because then that would be false. That's my not equal sign that's up there. And so there's our contradiction, and you always restate the proof. So the proof is FL not congruent to LH. Continuing on. And the triangle with sides 12 and 3 is given, and we got to prove the third side is less than 15. Right? So again, temporarily assume third side is greater than 15. Right? So you can either pick a number, you can pick 15, 16, whatever. We'll just say it's 15. We're going to say the third side is 15. Okay. Now what's the rule we just learned? The smallest two sides must add to be greater than the third side. Right? So again, that's the inequality from 5-5. So 12 plus 13 is 15. Is 15 greater than 15? Nope, that's false. Contradiction. So the third side must be less than 15. And again, notice, not a lot of reasons. I didn't write 2-column proof. There's a lot of flexibility in that. Someone could have said third side's 20. So that's greater than 15. You would have gotten the same problem. 15 is not greater than 20. Right? So a little bit of flexibility there. Next, we got a given triangle is not isosceles. Prove angle 1 not congruent to angle 2. Okay? So given triangle is ABC is not isosceles. ISO with an S for short. And then we're going to temporarily assume, and again, here's that phrase that tells you temporary assumption, that the proof is false. And so again, what's proof false look like? We take that not equal sign out of there. So if angle 1 and 2 are congruent, we've done this one before, kind of. AB and BC must be congruent. And therefore, the triangle must be isosceles. Again, what's our reason? Base angles convert. We use base angles to talk about the sides. And now, the triangle is isosceles, by definition, of what an isosceles triangle is. right? Isosceles triangle is a triangle that has at least two sides congruent, which is a complete contradiction of what we just talked about in step 1. So there's my contradiction. We're almost done. Angle 1 not congruent to angle 2 by contradiction. Given ABC is not isosceles, but this time mix it up. They're saying AB not equal to BC, makes it a little bit shorter, and angle BDA is congruent to BDC. Prove BD does not bisect AC. Again, pretty clear that it's by contradiction based on what's given to us. So I'm not going to write the in parentheses down. That's there to show you that. Trying to shorten it for you so that it's not like an 8 or 9 stepper. Step proof. So given right away, temporarily assume 2 that BD does bisect AC. Now this is one of the first ones we've had where the given, the opposite of the proved is not completed, right? We still have to use that. So what does something bisect something else mean? Right, we got to use our definition of bisect. And you also want to label your diagram for this one, because this is triangle not isosceles. We might need some information. So BD bisects AC, these are congruent. And again, looking at the diagram, they look like they shouldn't be. That is correct. They shouldn't be. This is part of our contradicting. Next, what else is in the given? BDA, congruent to BDC. That's in our given. So looking at my diagram, what's missing? I've got side angle, reflexive here, side angle, side. BD is congruent to itself. It's going to give me triangles congruent. That is not side angle side. It's reflexive, and then we have side angle side. There we go. Property or POC. Okay. Side angle side. Then triangles congruent. BDA, BDC congruent. Right, it seems like a lot of work. So I'm like, oh, why can't we do something quicker? We actually have to prove triangle congruent to get these congruent. Right, so AB and CB are congruent. Or the BC, or same thing. And there's our contradiction. Right, so we got the contradiction. You don't have to underline it, just showing you where our facts contradict each other. And then our contradiction is BD does not bisect, our final statement is BD does not bisect AC. And that wraps up today's lesson. If you have questions, feel free to ask. Answer key for the worksheet will be posted online.